As you've likely experienced, when we have a battery die in a circuit, the electronic device stops working. So batteries basically include a series of chemical reactions that occur within the battery in which electrons are transferred from one terminal to the other, the terminal being the positive or negative ends of the battery. Now, in order to move these electrons through the circuit, through the battery, from one terminal to another, this is going to require work. And if you remember from our study of work, work can be defined as a force times a distance, or it can be defined as the change in energy. And in the case of a circuit, we say that there is a potential difference, or voltage, that exists between these poles. That's why we have 1.5 volt batteries. That means that there is a difference in energy between those poles of 1.5 volts. And so that is one way we define voltage. So it's the potential difference between two poles of a battery. Maximum potential difference a power source can have as the electromotive force, or EMF. And we can represent that with a capital V. I usually put the little lines on the top, as you see here, just so that it's obviously a capital V and not a lowercase v for velocity. We measure voltage, or EMF, in volts. That's the unit. Now, because it's the amount of energy per charge, we can also measure it as joules per coulomb. So a volt is a joule per coulomb. And so again, there are a bunch of different ways you can represent this. You can call it voltage, potential difference, EMF. It's not actually a force, it's just the amount of energy needed to move each charge from one end of the battery to the other. Another characteristic of circuits is once you have these moving charges being moved by the voltage, they're going to create an electric current. And we determine how strong, how large that current is by knowing the net amount of charge that passes through a wire per unit time at any point in the wire. So basically, by using something called an ammeter, that's something used to measure current, that device will literally count the amount of charges going past per second. And so we can determine the current anywhere by knowing the change in charge, so the number of charges passing by, divided by the time interval that we were counting. And so we measure that in amperes. That's why we measure current with an ammeter. And another abbreviation for ampere is amps, or you can use a capital A. And essentially, it's the amount of coulombs per second. So again, 1 amp of current would mean 1 coulomb of charge passed by in 1 second. You need a voltage, a potential difference, to produce a current in a circuit. That's why if you don't put a battery in something that requires a battery, it doesn't work. Or if your cell phone battery dies, like it doesn't just turn on. You need a power source. You need a source of energy to move those electrons in order to have a flow of electrons. Now, through experimentation, we found that voltage is directly proportional to current. So remember that direct proportion means that as one value increases, the other one also increases. So as you have more voltage, you will get a larger current. When we plot this direct relationship, we see that voltage versus current gives us a linear graph with a linear slope, meaning that our slope is constant. And that constant that's holding these two variables directly proportional is going to be our resistance. And when we think of our equation of a line, y equals mx plus b, we would have voltage on our y-axis, current on our x-axis, and then that would make the resistance in the wire our slope. So on an Ohm's law graph, when you plot voltage versus current, you can then determine the resistance of the material in that circuit, what's slowing down those electrons, what's lowering or reducing or controlling the current. So again, Ohm's law states that voltage, aka potential difference measured in volts, will equal the current, which is the flow of charges in amperes, times the resistance in ohms. Now, just so you notice, like V, volts, R, resistance, I and current go together. I is usually thought of as intensity. And when you have a lot of current flowing through something, you'll have a really bright light bulb. And so back in the day, they would sometimes refer to it as intensity, and so that's where that I comes from. So now that we have some definitions for voltage, current, resistance, and their relationship to each other through Ohm's law, let's get into actually building circuits themselves. So a circuit is any continuous conducting path that connects the two terminals on a battery. We're going to draw diagrams to represent what we're going to construct virtually in the lab or in person. And this is how a battery will always be drawn. It'll always be two uneven parallel lines. Now it's really important that they're uneven because there is another circuit element that has even parallel lines. And so a battery must have uneven parallel lines. The longer side will always be the positive terminal of a battery. If you've ever put in batteries backwards to something, it doesn't quite always work. And that has to do with the direction that the current is flowing does matter. And so again, we designate that on our diagrams. The longer side of the battery represents the positive terminal of that battery. Circuit symbols we will be using include wires. So a wire with negligible resistance will just be a straight line. A resistor, again, has these zigzagging lines to show that it is difficult to travel through that circuit. You have a light bulb symbol. You can either do an X with a circle around it or two little loops for the filaments, the wire inside the light bulb. You can draw a switch as shown, and this switch happens to be open. And then you have an ammeter, which is used to measure current, and that would need to be placed in series with your circuit element. So if you're measuring the current through a resistor, it would need to be in a line with that resistor. And then the voltmeter needs to be measuring in parallel to that resistor. So series and parallel is something we'll discuss a little bit more as we explore circuits, but just know that an ammeter is designed to measure the current in the circuit and a voltmeter is designed to measure the voltage.